Hey everybody, it's time for another video here in chemistry, and this is a cool one. This is one of my favorites in the year, and you will see why in a minute. But to give you an idea of what's going on, we have a whole bunch of chemical bottles that, well, you'll see why. But I've also got this little guy here. It is a small beaker of hydrochloric acid, which is why I got my goggles out, because I'm not playing around. Everyone, remember, safety is what matters here. So, the other thing that I've got, which you can't see, is a small wire. Actually, I can grab it, right? It's a wire, nothing fancy. This is nickel cadmium wire, and the reason why we use nickel cadmium for this is that it does not melt at high temperature, or at least Bunsen burner temperature. We also have a Bunsen burner, clearly, or we wouldn't need this. So, right? Flame. Okay, I'm going to set this up so that you guys can see what we're doing. All right, we are all set up, and this is the way the video is going to look, which means for the most part, you're not going to see me in this one, which automatically makes this your favorite video of the year, right? So here's what we're going to do. I'm going to take these different things that are on here, which are on the data table that I've posted with this video for you guys to take data with. And what we're going to do is you're going to record the color at which it burns. Now, my NiCad wire does, right, I can put it in here for quite a bit of time. It takes quite a while before it starts to affect the color of the flame, right? And it isn't until it gets hot, like orange hot, that it produces that orange flame. If you see that color right there, that's not the metal. That is the wire itself. So ignore that color of orange. All right, so our first one is sodium chloride. If I can get some to stick to the wire, which I can't seem to do. There we go. So, sodium chloride. You guys remember what sodium chloride is? Sodium chloride is the other name of table salt, right? Now that's not the wire, because the wire took quite a bit before that it heated up enough to make that color, didn't it? That's the sodium. And I'm just touching it into the flame and pulling it back out so that the wire doesn't heat. So there we have a lovely orange color. All right, up next is one that I didn't use in the past. I don't know if this will do anything at all. So this is a new one for me. This is Cobalt Chloride. All of the metals that we're doing this with are chlorides, meaning so it's got the sodium chloride or cobalt chloride, strontium chloride. This is cobalt chloride. Ooh, look at that.
Yeah, it's orange-white.
It's orange. It's got a bit of white in it, but also look at what color. Look at what color it made the stuff on the end of the thing.
It made it blue.
It was red.
Before.
Right? It was red, and then I burnt it, and now it's blue.
What's the reason?
Interesting. Sorry, I'm gonna clean this off and get it ready for the next one, because there was a lot of gunk on there. All right, so that was cool. Like I said, I'd never done that one before. That one's new. Up next is potassium chloride. Potassium is another one of those ions that we need in our diet. What do you see there?
Kind of purplish.
That's purple. It's not the brightest, but there is definitely purple there.
It is the color.
All right. Now, we're going to try barium chloride. So barium, where is that on your periodic table? That's pretty orange. Is that significantly different than the sodium? We'll have to replay the footage side by side and see. But that's definitely orange. Just gonna burn the rest of the salt off here. All right. So we've done cobalt, we've done sodium, we've done barium, we've done potassium. Up next is lithium, in theory. I need to get more of this actually on the thing. It's not doing what it's supposed to. I'm gonna pause for just a second. All right, back. So the lithium chloride was kind of a rock, so I had to get it back into powder form so we could do this. And now I have some lithium chloride to add to the flame. Check that out. Do you see that? Okay, come on, that's cool. That's like so red it's almost magenta. That's one of my favorites. Boom! Oh, or rotate it a little bit so we can keep the color going. See? That's why I didn't skip it, even though the stuff was bad. But you think that one was cool. We have better ones coming up. So now, we've got if it'll work. It's not working. Same problem I had before with the lithium, but a little bit, we'll try it. This one is strontium chloride, and
What was that?
I'm gonna do that one again since I can only get a little bit of salt to stick to the wire at a time.
That was exact orange.
So it's different than the orange we had earlier with the sodium, and different than the magenta-y one from the lithium. That was strontium. And finally, the last one, we've reached the end of our tour of metals that form visible flame. This one is copper, and I'm sure you can guess what color copper chloride's going to create.
Whoa, green. Or
That's greenish blue, green and blue.
it's already a rainbow color.
And so we have that from the copper.
It's kind of like rainbow. Like I don't know how to explain it.
So, and just because that one's awesome, and because we've got a lot of copper chloride, I'm gonna do it again.
Just for fun. That's so cool. It's a rainbow.
So you got the green on there, you've got the blue, and then
purple and red.
we can get some white if we get it hot enough.
I can see a bit of white in the center. When this thing goes.
So, now the question is, why? Why did that happen? Can we answer that question? We can. So let's do it. You have a writing thing to go do. Good luck. Bye, everyone.
The power of science.